Imagine you're preparing for an exam and you have 100 practice questions. Only 10 of them come with fully worked solutions. The other 90 are just questions with no answers. A purely supervised approach would say, study only the 10 solved ones. An unsupervised approach would say, stare at all 100 and look for patterns. Semi-supervised learning does something smarter. It uses the 10 solved questions to learn how answers look and the 90 unsolved ones to understand the full shape of the exam. In previous episodes, supervised learning had a teacher, lots of labeled examples with the right answers. Unsupervised learning had no teacher at all, just raw data, no labels, and a search for hidden structure. Semi-supervised learning live in the middle. It assumes you have a small set of labeled data where humans have done the hard work of annotating, and a much larger pool of unlabeled data which would be too expensive or time-consuming to label by hand. In semi-supervised learning, the model first uses the labeled data to get an initial sense of the task, what counts as spam or not spam, toxic or safe, benign or malignant. Then it brings in the unlabeled data to refine its understanding of the overall data distribution. The intuition is this: even if you don't know the labels for most examples, their patterns and clusters still teach the model something about the shape of the problem. The labeled points act like anchor points, and the unlabeled points fill in the gaps between them. At this point, you might ask, why not just label all the data and stay purely supervised? In the real world, labeling is expensive, slow, and needs experts. Medical images often require trained radiologists or pathologists to decide whether a scan shows a tumor. Legal or financial documents need domain experts to label risk or compliance issues. Social media content moderation requires nuanced human judgment about context and culture. Meanwhile, raw data keeps growing. Millions of new posts, transactions, and images every day. Semi-supervised learning is a way to stretch a small labeling budget across a massive data stream. Consider content moderation on a large video or social platform. A small team of human reviewers can carefully label a subset of videos as safe, borderline, or harmful. That labeled set becomes the supervised core. But the platform also has millions of unlabeled videos. A semi-supervised system uses the labeled examples to learn what harmful content looks like, then leverages the unlabeled videos to discover additional patterns, new creators, new formats, and evolving trends. The result is a model that performs better than one trained only on the tiny labeled set without requiring humans to review every single upload. One way to think about semi-supervised learning is as a bridge. It extends supervised learning into regimes where labels are rare or expensive, and it tames unsupervised learning by anchoring clusters to a few known labels. In practice, it can reduce the need for massive labeling efforts, boost model accuracy compared to using labeled data alone, and adapt faster to new patterns in the unlabeled stream. As data grows faster than human labeling capacity, semi-supervised techniques become more attractive in domains from fraud detection and recommendation systems to document classification. In upcoming episodes, we look at other ways AI learns from interaction and feedback, including reinforcement learning and human-in-the-loop systems.